Barbara Lee. I'm a member of the board of the Princeton Adult School. It's a real pleasure, both personally and professionally for me tonight, to introduce you to Larry Peterson. Larry is a friend, an old friend. Watched him coach Little League Baseball for many years, his sons and my son. And he actually also has a day job. He is the Robert E. Kahn Professor of Computer Science and director of the Princeton-hosted PlanetLab consortium here at the university. He served as chair of the Computer Science Department from 2003 to 2009, so he's just gotten sprung from that assignment. He's the co-author of the best-selling networking textbook called Computer Networks, A Systems Approach, and chaired the initial planning efforts that led to NSF's GENIE, is that the right pronunciation? GENIE initiative. And GENIE stands for Global Environment for Network Innovations, a project sponsored by the National Science Foundation, which is open and broadly inclusive, providing collaborative and exploratory environments for academia, industry, and the public to catalyze groundbreaking discoveries and innovation in these emerging global networks. Professor Peterson's research focuses on the design and implementation of networked systems. Some of his recent projects and papers include experience-driven experimental systems research, container-based operating system virtualization, a scalable, high-performing alternative to hypervisors, and experiences building PlanetLab. He's the editor-in-chief of a prestigious journal. He's been on the editorial board of other very prestigious journals. He served as a program chair for a number of scholarly organizations. He's a fellow of the ACM and the IEEE, and I do know what the IEEE is because that's right next door to where I work, and is the 2010 recipient of the IEEE Kobayashi Computer and Communication Award. He received his PhD from Purdue University, and the title of his lecture is The Internet of the Future. I don't think there's anybody better qualified to talk about this subject tonight, so please welcome Larry Peterson.
Thank you. So I thought for a while about how I should go about doing this talk. I do want to give you a broad introduction to what's going on in the internet, but I also wanted to talk about my research. And so I'm going to, of course, try to do both. And I'm going to try to do it in the allotted hour. I thought what I'd do is to look backwards a little bit over the last few years because there have been some very dramatic changes, both in the internet and how the community I'm involved in goes about thinking about the internet and trying to introduce new capabilities into the internet. And then based upon that foundation, give you just a sense of my perspective and where I come from, then start looking forward a little bit onto some of the things that I see on the horizon through the lens of what I do, of course. But I wanted to try to give you, as you see here, this set of topics, and I could go on for an hour or so on each one of these, but I'm going to try to just hit a couple of key points and, of course, take your questions at the end. Broadband access, this is what you do at home when you connect to your Fios connection or your cable connection. So you're the end user, your perspective a little bit. Take a look at the operator's perspective. This would be Verizon's perspective or AT&T's perspective, Comcast's perspective. Society is having a lot to say about what's going on in the internet, and I'll give you my personal experiences with those issues. There are a lot of them here. We tend to think of the internet as something that belongs to the U.S. It had its early beginnings here, but it is now the world's internet. And while we've done a pretty decent job connecting the first billion to the internet, we have to start looking to the next billion and what we're going to do to help connect them. And finally, most forward-looking is cloud computing, which maybe you've heard that buzzword, and I'll just give you a couple of words about what my perspective on that is. So I'm going to take you back 7, 8 years ago now. In my view, as a researcher trying to think about what the internet ought to be, there was a pretty wide recognition that, of course, the internet, even at that point, was wildly successful commercially in terms of its reach and its impact on society. When you go back, a half dozen years or so, we all had heard of the internet, and we were all using it. But that came with a somewhat unexpected, or perhaps not unexpected, cost, which is ossification. That is, it had become such an important part of our lives that we could no longer change it and try to make it better. It was a fixed piece of infrastructure. So if you just think of infrastructure generally, how difficult it is to put in new roads or build new airports or whatnot, it's just as hard to change the software infrastructure that we have in place. We depend on it. You can't just go yanking it out and replacing it with something else. And we all recognized there were lots of vulnerabilities. Security is sort of at the top of that list, but there have been others. And so we were really concerned about how we were going to innovate and do anything that addressed these vulnerabilities, or for that matter, just introduce new capabilities. And both, I think, commercially and in the academic world, we had gotten to the point that we were twiddling the last couple of bits trying to fix the little tiny problems, and we were completely ignoring the big problems. And several things started to happen, one of which I was involved with, which is PlanetLab, which is hosted here at Princeton, but it's a global network. Genie is a sort of a larger follow-on version of that you heard about. But PlanetLab's a pretty simple idea, and that is we'll just take some regular PCs, regular computers, and we'll spread them around the world, and we'll connect them to the internet. And so we've done that. And the way it works is that as an organization, you get to opt in, and if you host machines, then you get to use the machines everyone else is hosting. So it's a very cooperative sort of thing. And then we let researchers or anyone that has an idea they want to try out to create that new internet of the future use this platform to experiment with their ideas. And they can do whatever they want. And so the way we think about it, the technology is that each of those experimenters gets a slice of the global facility. And so the way that you can visualize that is the cloud is the internet, and the boxes are machines that have been spread all over the world. Some of them live in the building next door. Some of them live in the very core of the internet in the routing centers and the co-location centers of the internet. And through the use of virtualization software, I can give a certain researcher a blue slice, and they can go off and do whatever they want. And I can give another researcher a red slice, and they can do something completely different, completely innovative, and not constrained at all by what the internet does today. And because of the way we have virtualized this physical infrastructure, these two researchers can concurrently try their new ideas without interfering with each other and without interfering with the internet underneath, pretty much. One of the things that we wanted to learn is what happens if real users start to use this. I mean, I really haven't learned about the new red idea unless a real user tries to use it. If I just use it to ship files full of zeros around, I only learn so much. But if real users are using it, we learn a lot more. And actually, that will be some of the comments that I have a little bit later on. But in any case, what this was all about was trying to leap the innovation gap, for lack of a standard term for this. You think of us in the ivory tower doing all of the analysis. I've got a great idea. I'm going to do the back of the envelope calculation. I'm going to do some mathematical analysis. I will do some simulation. I'll say, this is a great idea. Cisco, adopt it. And of course, they're not going to. They need a lot more demonstration that this idea is going to work. And so we recognized that we were becoming irrelevant in the academic community because even though we invented the internet in the academic community, it's the experiment that escaped from the lab. And we no longer had the ability to go out and try something new because ossification, it's fixed, it's too critical. We can't go tinkering with it anymore. We used to play with it. We don't get to play with it anymore. So how do we take the ideas that we have and develop them and allow them to mature so that we can get them out there and in widespread use? Well, the thing that we in academic world have been doing for a long time is we will take it the next step and we'll build a prototype, but it'll run in the lab. This gives us a little bit of a reality check. Can you actually make this, program this thing to work? But it's still a long leap from there to commercial viability. Oh, and I should say I'm focused on the academic community because that's where I live. I think as I have seen it, the problem was just as bad in the commercial world. If you go to AT&T, which has a lot of network infrastructure, but that infrastructure is so critical, they don't let their innovators do anything innovative with it. They get to tinker around the edges if there's a need for a new feature from a client, but in terms of trying anything at all radical, they're stuck with the old infrastructure in the same way we were. So this is not unique to the academic world. But in any case, this is where PlanetLab came along. We could now build completely new services, new capabilities, try to address current vulnerabilities, and then deploy it out in the real world. And so this isn't the controlled experiment where you try an experiment and you change one variable and you try it again and you see sort of all the engineering parameters. This is set this thing out there in the wild and see what happens. And users that we've never met will start using this, and then we'll learn how they use it and how it behaves over months and years. So this is why I call it a deployment study instead of a controlled experiment. Well, this is where PlanetLab started, and there have been hundreds of researchers that have done that, and they've developed services. A few of them have gone off to startups, and lots of papers have been written. But we realized after a while that there was still a bit of a gap, and so there's this other thing that you have to do before you can quite get to the commercial adoption. And I just needed another word, so I call it a pilot demonstration. You find an actual client that one day might pay for it and let them use it for free, because they start telling you requirements that you didn't think of before. And this just gets you a little bit closer to all of that stuff you've got to do to take an idea and make it a commercially viable idea. And so we have found some scenarios where we have a user community. Most of the time they're nonprofit, but not always, where we'll say, you've got a problem, we've got a solution, let's see if these two things work together. So just as an illustrated example, content distribution is a place that the research community has spent a lot of time, and we have here at Princeton as well. We started out with some great algorithms, sort of typical scenario. We did a simulation, and it was 91% better. That's a typical academic paper. But then we created a system, wrote a lot of software, and deployed it in PlanetLab. And we get 25 million users a day that use it. We learn a lot from 25 million users. In fact, we've learned a lot over the years, and we keep iterating on this, and we discover a new problem that we didn't recognize was there yesterday. The problem with simulation is that you only simulate the parameters you know. And so if you didn't anticipate a problem, you don't correct for it. And we discovered lots and lots of problems that we had never anticipated. And by going off and doing what turned out in the academic world to be a lot of work, this is pretty atypical, we tripped over a lot of problems and did the academic thing and wrote a lot of papers. But we kept improving this service to the point that we started offering pilot demonstrations and recreated the system. It's now called CoBlitz instead of Codeine. Codeine was to ease your pain of carrying content. CoBlitz gets it there very, very fast. Just blitz you from all directions. And we found some users that wanted to use it. And so you may recognize some of these, but World of Warcraft is an online game, and every now and then they put out a patch or a new game or an update, and millions of people around the world try to download it. And that puts a tremendous load on the servers that are trying to offer that up. What a content distribution network does is spread that load across the internet so it smooths it all out and everyone can get more download of whatever the content is. Anyway, we learned a lot. In fact, we went into a European telco and got to deploy it inside of their R&D network, which was a great opportunity for us. In fact, we're so good at choosing names, we called this CoBlitz. The European telco was the Polish telecom. And so there was a while there that we weren't sure that CoBlitz was going to go over very well, but they finally decided it wasn't such a bad deal. And in fact, this is now spinning off commercially and carries commercial traffic today. So sort of a validation of this pipeline of moving innovations through the system. All right, so that's the background, the recent past. And I don't mean to imply that all innovation in the internet has happened with PlanetLab. That's been one avenue. But there have been a few others things that have happened like that, including some very large companies that have the resources to do this, investing in creating the kind of infrastructure out there that their innovators can then go and play with and offer up new services. And I'm speaking specifically of Google. They're a real game changer in terms of how they are willing to innovate and create new definitions in the internet in very much the same way the community I was just talking about. But that wasn't there 6-7 years ago. We were really stuck on worrying about how to interpret one bit in the packet headers, and it was a really depressing situation to be in. So let me start looking ahead, and I'll spend a few minutes on each one of these points, starting with broadband access. So this is about how in your home you go and buy service from Comcast or Verizon or whoever, and it's how the vast majority of people access the internet. Well, in fact, I don't know what the most recent numbers are, but we're probably talking 2/3 of the U.S. have broadband access now. But there's another third or so that don't, and globally, of course, there's some countries do much better and some much worse. But here in the U.S., part of the stimulus package, the ARRA, was set aside $7 billion to go off and invest in broadband access into areas that didn't have it or were completely underserved. So that's an investment they're trying to figure out exactly how to go about spending that money right now. Coincidentally, at the same time, there is a lot of talk that you may have heard about network neutrality, which one way of thinking about it is if the network is in fact neutral, then you can't put restrictions on content, sites, platforms, modes of communication, and you can't unreasonably degrade one set of traffic in favor of another set. So the network is blind, it treats all data the same, and as a carrier of traffic, you can't go out making it difficult to get to this site, but making it very fast to get to that site. So that's the core of the issue with net neutrality, should that be the case or not. And in fact, in situations where there has been blatant, unreasonable bias in favor or against traffic, that has been so far. I'm not exactly sure of the legal status of it, but it is something strongly frowned upon, and at least through peer pressure, is not happening. And the companies have backed off of doing that, although it's still a very contentious issue. Well, the question is, how do you measure the effectiveness of spending $7 billion on the one hand, or how do you measure the behavior of ISPs? We just don't know what it means to get the 10 megabit service from Fios from Verizon, or for any other carrier for that matter. And so just a year ago, almost right now, we started a joint effort with Google and a few others to create something called MLab, or Measurement Lab. So MLab is PlanetLab in the background, and a web interface that every one of you can go try as soon as you get home to see if you're getting the broadband connection you thought you're paying for from your carrier. And I think as of tomorrow, the FCC will start using this as a way of evaluating broadband access in the U.S. So just a little very quick demo just to illustrate one important point, which is how bad we are at user interfaces. www.measurementlab.org. If you go there, either as a user or as a researcher, see, the researchers want you to test your broadband connection because then we get to collect data. So it's serving two communities, but as a user, if you go here, you can test your internet connection. And there's several tools, but you want to use the first one. And I'm not going to explain the tool. I didn't do it. Other researchers did it. So I'm just providing the platform that this tool runs on. So at, I don't know where we are. You can see all these cities here now host machines. And what's happening is you're testing between your home and a machine in Paris or Athens or wherever. And you could pick one, but it turns out that someone on PlanetLab built a tool to automatically pick one for you. So we'll go ahead and use that tool. And it will pick the one in New York, not surprisingly. And if you just come down and say, OK, let me test this connection, and I'll start. There are other tests like this. This will take a couple of seconds to run that you may have tried. There's speed test. There's some other ones like that. And they'll show you a speedometer going, which much more impressive graphically than what I'm showing you here. But they tell you much, much less. This tool was designed to tell you everything between you and the site that you're connecting to, which happens to be in New York, and where the bottleneck is, and who's at fault, and why it's congested, and so on. And some of these other tools will tell you if you're using BitTorrent to download movies, legally or illegally, whether your carrier is biasing, shaping your traffic so that you can't do that. It's taking bandwidth away from you, which they're not supposed to. Well, I'm doing this wireless at Princeton University, so I've got 45 megabit connection, which is pretty good. But you'll see that I'm getting a client-to-server bandwidth of just under a megabit. But the interesting thing is that it's telling me that it's network congestion that's the problem. It's not that I got a faulty link or something else. It's that enough other people are trying to use that 45 megabits that it is limiting how much I get. And given that we are at 8:30 at a university campus, there's probably a movie or two being downloaded right now that I am competing with. I think at the FCC site, they're going to have a different user interface that has a speedometer. But this is the one that the tool comes with. All right, so the point here, get back to my slides, is that we can now understand what the network is. Well, this was announced actually a year ago. I'm showing myself at the press conference, and this is the researcher caught in the headlights moment. So the gentleman sitting next to me is Vincent, who is at Google and one of the two co-founders of the Internet. Ed Felton is my colleague here at Princeton. And I'm explaining to everyone why all the data we're going to collect is going to be so wonderful. We're going to do all this great research and so on. But what I didn't realize is this press conference is about Google at war against AT&T and Verizon and everything to do with network neutrality. In fact, after I did my little spiel, someone from Verizon got up and asked, well, if this thing tells you such and such, then how did you know it wasn't your laptop that was at fault? Why do you know that that means that it was Verizon's network or the telco's network? At which point I had to bite my tongue a little bit because I explained academically that, well, the tests are designed such that you can evaluate the factors and so on. But the truth of the matter is, at that very moment, I was in a fight with Verizon at home trying to get my FiOS to work. and I knew a little bit about networking, and I knew that it was not because I was using an Apple and they'd only certified PCs to do the tests. I knew there was something wrong, and approximately what it was, because I could basically look at the data I just showed you. And it took me several weeks to get them to finally change a parameter on their router, and they finally got my bandwidth. But that's the kind of thing that as a consumer, it's very, very hard to know. As soon as we posted this, we were getting mail from people all over the world saying, now I know what Comcast is doing to me, or Verizon, or AT&T, not to pick on any given one. I've been fighting this battle for months now, and now I've got the data. And that's really what this is about. Net neutrality is how it gets discussed in the press, because Google wants the network to be neutral and the providers want the ability to make money. I'm not going to pick a side, except to say that what we really needed is to empower consumers to have network transparency so that they could understand what was happening and then they could choose. It's fine with me if I pay this much money and I understand that you're going to throttle my BitTorrent. That's fine. I don't really download movies off BitTorrent. Or not. And so the more transparent this is, as consumers, you can make the best choice for yourself, and different providers can offer different services, and that's perfectly fine. Okay, so that's the first topic, and it continues to be a big one. Second topic, content networking. So the thing we have to understand is that the Internet, which is IP as opposed to the cell phone network and some other networks, they're all converging on IP. Content that is being delivered is growing at a rate of about 65% a year, which means it's doubling every 18 months. The amount of content being downloaded on the Internet is doubling every 18 months. High-definition video, first video and then high-definition video is what's driving that. So now we're getting in a little bit into the perspective of the network operators, the guys I was just picking on a minute ago. It's a good news, bad news situation for them. Geez, that's a lot of content. Surely they can make a lot of money. They own the network infrastructure. They own the fibers. They own all of the switches and so on. And it's the fiber that comes to your doorstep. So it's not like someone else can come in and cut in front of them and offer that same thing. Everything has to go through their capabilities. There's like maybe 2 choices into your house. The bad news is that they have no idea how to deal with content. All they understand is they've got pipes and they push bits down it as fast as they can. But with this kind of load, it doesn't matter how many pipes they've got, it's not going to scale up to handle the load. And there's another problem, which I'll explain what this means in just a second. They have business customers, and they can charge their business customers to deliver content from their customer to their subscribers, and they can make money doing that. But there's other content being produced by people that are not their business clients, their customers, and that's called over-the-top content. They have to carry it to their subscribers, but they get no revenue for that. In fact, it costs them money. And so let me sort of start back at the beginning just a little bit. From the perspective of the network operators, and I typically talk about telcos, so AT&T, Verizon, and then the like in the US, France Telecom, British Telecom, Polish Telecom, and so on. They all have this managed and unmanaged and mobile network that they're dealing with. But what they're seeing is, at a whole new level, they're having to carry content. And what they really need, what they've come to understand that they need, is a content delivery network, which is something more than just the pipes and the fibers. And so you have all of these sources of content, and I'm just showing some examples. You've got live video, video on demand, YouTube, and what you now think of just as a traditional web server, pumping content into the content network, and the subscribers at the other end, whether it's just your web browser, your television, or whatever, your handheld device, are pulling content out. And so the challenge here for them is how to effectively move the content, and distribute the content, and deliver the content throughout that network. And again, it's more than just, here's some content, let's give it to everyone, because if I have to deliver the same content to 1 million users, I probably just used 1 million times my bandwidth capacity that I should have. So I'll get to the solution in just a second. That's the problem. They're trying to figure out how to just deal with this world. Not only is it the volume, but it's the different kinds of content being produced. Well, let's just focus narrowly on YouTube for a second. The average user YouTubes 3 hours and 46 minutes a day. In this particular study, this is an entire country in Europe. This is a European country, but I have no reason to believe this is any different anywhere else. If you're a subscriber that's paid for the broadband, then you're using it. And these are just traces of, they're using it on a very regular basis. And this rate is doubling every month. So the problem with YouTube is, in particular, and its type, is the following. So think of this from the point of view of the network operator. They've got their network. Okay? And they're serving content to subscribers that have, that paid their $19.95 a month to connect, whatever, $100 a month. And they're connecting their network by a router to the rest of the internet. Sometimes it's just at one point. For some larger providers, it's more than one connection point. And somewhere on the other side of the internet are giant sources of content. And YouTube is one of those. So this basically has to come across the internet, however it gets there. It goes across that router into the operator network, and then it has to be distributed throughout the operator's network to get to the edge. The problem is, first, the operator does not get to charge YouTube a nickel to do that. So there's no revenue being generated. And they have to actually pay. They are a customer of the upstream provider, the upstream carrier, and they're paying what's called peering costs to pull that content over. So this is the worst possible scenario. They get no revenue, and they have to pay money to pull content in. And then internally, it costs them as well. I'll get to that in my next slide. But just pulling across the peering point is a major, major source of pain for the operators. And more and more content is being delivered. Video content is being delivered via YouTube. You may think of YouTube as a place that funny videos get uploaded, but YouTube is now really the collection point for videos being produced by everybody. And so if you've got content and you want to make it available to the world as part of your business, you don't necessarily put the content on your the video on your web page. You make it available through YouTube. So YouTube is becoming the video distribution source management center of the world. That is part of what's going on. And then Google, of course, gets to do their thing with ads. So that roughly is where the business is headed. Not good news for the operators. They own the infrastructure that gets it to the user, but they have to pay this cost. If you crack open the operator network, you'll see something that looks a little bit like this. They will have a set of very well-connected data centers. So in the US, we call these the NFL cities. So these are the big centers. Very, very high bandwidth between them. And it's hard for me to show in this slide. I didn't do a very good job with the graphics, but that will fan out to a set of central offices. There's actually a central office right across the street, sometimes called a POP, a point of presence. And there will be switches and routing gear there, and that will fan out to the DSLAMs and the access points. The DSLAMs are what sit at your curbside. The access points are the wireless access points in various places. And that then fans out to a set of subscribers. So there's a giant fan out that happens. Okay? One of these backbone routers, by the way, is the one that's connected to the internet. One or more of them, but think of even just one. So I'm not showing that here, but this is where I'm connected to the internet. So every one of those videos that comes in, I have to pay the cost of getting it across there every time one of my million users want to look at it. And then I've got to spread it across my internal network, delivering it probably multiple times across the internal network. So every one of these videos is consuming bandwidth of my internal links over and over and over again. So the reason I'm saying that content delivery is sort of the next big thing on top of the pipes that we've got there now is that it's really all about the network infrastructure and the storage that goes along with it. And so what a content distribution network is, and Codeine and Coblitz are examples of that, is basically the software to take a set of commodity processors, each of which have some disks in them, and co-locate them with all of the routing centers and central offices and so on, and in fact put them, if you can get the form factor right, way, way out at the access networks, except I can get lots and lots of them back here, and I can get just a few of them in my local central office, and I can maybe only get one disk and one processor out at the edge. But I have created a distributed storage system. And what a CDN or a content distribution network is all about is the logic of spreading the content throughout my network, storing it or caching it, so that when someone wants to look at this video for the nth time, I can just go to the local copy and pull it out. And I don't have to pay the pairing costs, and I don't even have to send it across the internal network multiple times. So that's the technology they need. There is some crude content delivery technology out there from years ago that is very low performant and doesn't go out to the edge very well, but that's where some of the innovations on PlanetLab created a new generation of technologies that are finding their way into these carrier networks, which is critically important to them as they scale up. This also can cache the data that comes across on YouTube as well, although there's some technical difficulties in doing that. Okay, so that's the CDN story. Let me move on to the policy story. I've already talked about network neutrality a little bit, but the issues of running a network touch on policy and legal and social issues at many, many, many points. And I've just listed a few of them. I don't know if you saw the news late last week, but a judge in Italy ruled against some Google executives because Google was carrying a YouTube video. Google owns YouTube. Google was carrying a YouTube video that violated the privacy of somebody. And the privacy laws in Europe are much, much stronger. They take privacy much, much more seriously than we do in the States. We tend to take freedom of speech more seriously. And so we've got freedom of speech and privacy rights at odds with each other. That's a great debate. I'm actually scared to death by the other thing that this really means, which is that Google is liable for content that they just carried. They didn't produce it. It was just, as someone who thinks about, I carry content and sometimes I store it for a little while until I can deliver it. If I'm held responsible for what that content is, that's a scary thing. And the carriers have never been held responsible. They've always been exempt from the bits that go down the pipes, not the carrier's fault or the ISP's fault. It's whoever produced the content. And so this ruling turned that on its head. Another thing that comes up a lot on the internet is whether you are anonymous in what you do or if you're held accountable. The internet is biased towards your being anonymous, and we do very little accountability, which is why you have so much spam and all of this bad stuff going on. That's an issue that comes up over and over again, as does the issue of carrying copyrighted information, the BitTorrent problem. So digital rights management is a huge issue. And simple questions about, I'm doing this for the public good, but no, you're using my computer, so I'm not going to let you. Public good versus property rights is a question that comes up over and over. Now, you would think that these are, the Googles of the world and AT&Ts of the world have a whole cadre of lawyers that are fighting these issues all the time. But we have a saying in my lab, which is if you don't know the university's general counsel, you're not doing network research. So what I'm going to show you is what I deal with, which might be shocking, running an experimental network. But it's and I'm not going to talk about all of these issues. That's a huge number, but just some things that I have seen. So DMCA violations are the bane of my existence right now. This is the Digital Millennium Copyright Act, which is the legal statute that keeps you from, that defines penalties for distributing copyrighted material. So there's a lot of players here. There's a copyright holder, think Disney, right? They will then contract with a notifying agent, a company whose expertise is detecting when somebody violates copyright, and then they notify that party that they're in violation. That's their job. They send an infringement notice to the violator, and if it's a university, it's the hosting site, not the individual student. They just know it's a machine at Princeton, so they send it to the provost. Not the provost here, but every university now has a DMCA officer that's responsible for fielding these. And in all the universities, it reports to the provost, and so I see plenty of email from provosts. And if it happened to be a PlanetLab machine, if it's a Princeton machine, Princeton will just go deal with it. But as soon as they see it's a PlanetLab machine, they forward the complaint to me. And this happens at 500 universities around the world. universities and research labs. Usually they turn the machine off first, and then they send it to me, and then I have to get them to turn the machine back on. I asked the researchers for an explanation, and it turns out to be a false positive. There was really no copyright infringement. So what's going on? Well, here's an example takedown notice. This one comes from, this is the notifying authority known as the Video Protection Alliance. They were under contract with a copyright holder that I will not name. And the notice, I've just put in bold so that you can sort of get the sense of it. The identified computer appears to be making copyrighted material available to others, blah, blah, blah. You are probably using BitTorrent. Violation of copyright law is a federal offense. This is a threatening note. Provosts do not like to get this. And as a user, if you were to do this from home, you might get something like this, and you wouldn't like to get it either. And in fact, if you did, you would be scared to death. All right? Legal action, you can be sued, you can be thrown in jail. Fortunately, the Video Protection Alliance gives you 4 easy steps to make the problem go away. This just blew me away. I don't know what the definition exactly legally is of extortion, but I know we're coming dangerously close to it. What standards were the VPA held to when they sent me this threatening email? Had I really violated copyrighted DMCA? Did I really have copyrighted material? Was I doing something illegal? Or is it just a shot in the dark? If I was worried that maybe I had violated somebody's copyright, I might, through 4 easy steps, pay them I think it's like $25, and the problem just goes away. All right, so now we've got a scenario that I had never thought of before, but I suppose just straight out and out blackmail is, you're maybe worried about embarrassment, but you could be worried about legalities of something, and you're being threatened, all right? So we're dangerously close to that. Well, it turns out that there was no copyrighted material, and there have been many occasions, this happens about once a month. There have been several occasions. In this particular case, one of those content distribution networks was not carrying content, it was carrying a cached copy of the file that said who had the content. These are called trackers in BitTorrent. And so, first of all, it was just caching. It was not the sources of this information. It was just temporarily caching, because that's what CDNs do. And second of all, it wasn't the illegal content. It was just a list of who had the content. And there have been other times that other researchers have done other things. They've been measuring, talking to trackers just as part of a research experiment to find out. In any case, it was definitely a false positive. This one, because of the suspect notion of making the problem just go away, and the very low standard that the notifying agents had been held to in terms of when did they generate one of these messages, the outcome of this happened to be that the copyright holders, the notifier, the VPA, fired their subcontractor, go get me a better piece of software to detect copyright infringement. Basically, there is a very low standard for when you have in fact violated the copyright, and you get one of those notices. Earlier, we've had run-ins with the motion picture industry, and we finally got them to agree just to whitelist the PlanetLab note. So if they ever get suspicious copyright notification and it was a PlanetLab note, they just ignore it and trust us that we're not holding copyrighted material. Here's another set of things that we deal with. This first one is I'll just focus on the first one. Who the hell are you, and why are you interrupting my Facebook access? The other variant of this is, who the hell are you, and why did you install spyware on my machine? The second one is from a carrier, an ISP, and they, on behalf of a content provider, are noticing that there's an extra lot of traffic. The third one is a particular content provider, in this case the government, who says, we're getting a lot of traffic from you, what's going on? And the last one is from a university that is hosting one of our machines, and they're suspecting that we've been infiltrated by a virus and doing all kinds of bad things. Let me just remind you that what a content distribution network is a whole bunch of stuff that sits between the content source and the content consumer, doing a good job of getting the content there. So instead of directly talking to this web server to get the content, you're talking to the CDN who will get the content to you on behalf of the web server. But this agent in the middle causes all kinds of confusion. And so if you're an end user and suddenly a CDN is delivering this data to you, you might be confused by that, but there's actually something a little bit stranger going on. users like to surf the web anonymously. And one way that you can do that is download software that promises to anonymize your web access. So you can't tell where you've been visiting. There's actually very legitimate reasons for doing that. If you knew what they know about you because of the websites you visit, it would be absolutely shocking. I won't talk about that. So I'm not saying that all of this is bad, but there's just users that want to anonymize their access to the web. So they load this application. What this application does is it goes and finds a list of what are called open proxies, which are basically servers that you can indirect through. So I go to the open proxy, and the open proxy will go to the web server for me, and that's how I get to be a little bit anonymous. But they let you do all kinds of really, really bad stuff. Most spam that you get has been redirected off of an open proxy, so they're viewed very, very suspiciously. Coding, this experimental CDN, is mistaken for an open proxy. And so these users who think they're anonymously surfing the web because they downloaded some anonymization software suddenly start surfing the web via coding, which doesn't let them do what they wanted to do. Doesn't let them send their spam. And so they get upset. On the flip side, the content providers and their ISPs can complain about unusual download activity. And it is unusual. It's coming from this set of nodes that keep downloading stuff over and over again on behalf of the real consumers. The hosting sites that are hosting all these nodes mistaken coding for an open proxy. So the strange scenario that we find ourselves in is trying to do a better job of delivering content, being accused by universities of doing bad things, running open proxies, being accused by the users of not doing bad things because our open proxies aren't real open proxies. So you're damned if you do and you're damned if you don't. But the problem is, this is a fundamental problem with the internet, trying to inject a new capability into the internet by tricking people. I trick both the content producer and the content consumer to send their traffic via this intermediate bit of software, just raises all kinds of red flags. Okay, we could go on policy all night long, but let's move on to the next topic. The next billion. Now, I'm not talking about the people that need medical health care and clean water. I'm talking about the next billion after the first billion. They typically are lacking in communication infrastructure, but not in the basic necessities. So, yes, there are other problems, but we can still address the next billion. So these are in developing regions. There have been some very visible projects. The one laptop per child is one of those. Intel had the classmate project. I just happen to have a classmate with you. It's basically, let's give all the kids in the school a $100 laptop and just let them go to town with it. And there are other examples I've got a list here, and some of which we've been working with in various pilots. The challenge here is that their backhaul link from the school or the village back to the internet is very poor. The servers that they can put into their schools, I'm not talking about the laptops, but the server that is the interface, the connection point between the laptops and the outside world, are very under-provisioned, and they have virtually no IT expertise. And so, just a quick slide to convince you, although there are probably 100 others. This one example in Ghana that we are basically giving local technicians the ability to upload images, so the ultrasound images, so that an expert at the other end can evaluate them. This is the kind of thing that you enable, not to mention all the kids in the schools. So here is an example deployment that we're doing, my colleagues and I, in Ghana. So we've got the internet, and at some point in the internet, just happens to be London, there is a satellite uplink that at a very meager 256 bits per second is serving all of Ghana, all of these Ghana universities. And if you sort of blow up what you find at one of those universities, there's going to be some local server there. So what we've deployed is a capability on both sides of that bad or weak satellite connection. On the Ghana side, we have a really great cache, and what makes it really ability to cache lots and lots of data. And what makes it great is the technology we've developed for our world is going to put some very expensive servers down and say, okay, here's your web cache. That'll be $30,000, please. If you're spending $100 or $200 per laptop, you would like to not spend $30,000 on a web proxy or web cache. And so what we've done is we've taken basically this technology and we've stuck a $100 terabyte disk on it, and we've turned it into a web cache. That's a little trickier than it might sound because we can do that with very, very little memory, which this has in it. And web caches tend to use lots and lots of memory because they have to index all the data they have. But you can now, for $300, build a cache that goes at that other side, and it will basically give you a 2x improvement over your capacity because it caches stuff you don't have to go across the link. But at the other side, we only transmit new data, the differences from what we've transmitted before. This is called WAN acceleration, and you get a 10x improvement. So at a very low investment, you can dramatically improve the capacity of these links and get more bandwidth effectively across them. Okay, let me conclude by talking about cloud computing. This is something that you may be hearing a little bit about, and if you use Gmail, you are using cloud computing. If you use Google Docs, you're using cloud computing. Amazon offers a service called the Elastic Cloud, EC2. The drivers for cloud computing, basically, the one-liner is it's everything you do in your desktop, but do it in the net. So your desktop, your laptop is just the interface, and everything's really happening in the net. You don't have to get the latest version of Microsoft Word. You just use the Word that's in the net. And same for spreadsheets and so on. This has two advantages. One, it gets you out of the IT business. You can just connect to a web page and suddenly you have access to all of these services, so you don't have to have the latest IT stuff. And even entire departments here on campus and elsewhere are starting to outsource what used to be their internal IT. They're getting it from the outside now because it's just cheaper for those guys to do it. The other thing is that if you're looking for a service that you can grow over time, this is a pay-as-you-go. If I need this much service, I pay for this much service. I need this much service, I pay for that. If you have to build it yourself, you have to go buy entire chunks of hardware and provision for the worst case, and that's just a much more expensive thing to do. There is an ongoing debate here, which is the cloud gigantic, enormous data centers? And I don't know if you've ever seen stories about data centers, but these are huge, self-contained units, powered, and so on. And in fact, the latest thing that's going to happen is we're going to move them all to Iceland because they have cheap energy. And so, Iceland's not that far away. And so we just locate all of our computing resources in one location. And then we say the network's not a problem. It's 10 milliseconds to Iceland, no big deal. So that's the way the network is viewed. The other point of view is that the network actually brings you value. And what the data center is just one piece. Everything it is, in fact, the entirety of the network that's bringing you to the service. I happen to be from the latter camp, and I'll show you the way that I would view it. So the other way of thinking about what the cloud is about is it's simply the ability to scale a service. The whole power of the internet is that applications are implemented software running on the general purpose processors that live at the edge of the network. The internet is the success it is today because anybody could go off and write a new internet application. And lots of anybody's did that. But as those applications become popular, Facebook, YouTube, Gmail, as these started out with a web server, I understand how to do that. As they became popular, I have to scale the services by migrating them into the infrastructure, into the network. And so the key, in my view, is that the substrate should lower the barrier to entry. It should be easy for you with a good idea to create at very low cost a demonstration of your idea and then scale it up over time. But if you've got to go out and provision this and buy that and get it stuck in the racks and visit the facility down in McLean, Virginia every 2 weeks, that's just a huge barrier to entry. So there are people that are offering that. In fact, my view of what goes into that cloud is that it looks a whole lot like what we've been building all along, which is capacity, generally programmable, that can be shared. I can do my service and you can do your service, and we can scale it up over time as demand requires. And in fact, this is my picture of the cloud. It's exactly what I showed you before. It is computing embedded everywhere in the network, all the way from the giant data centers, including the extra giant ones in Iceland that I'm not showing, all the way down to the little bit of computing that is in your curbside. In fact, it probably runs in your set-top box next to your television as well. And in fact, the technology that we use to deploy the CDN is exactly the same thing, except now all those blue places are places I can plug new services in. So the moral of this story is content is what gets the capacity out there. I've already told you why that's going to happen. Once I've got general purpose processors out there and I know how to slice them, that's the opportunity for you to do your service and the next fellow to do his service and so on in the same way that we've already been demonstrating for the last 6 or 7 years as possible. So let me wrap up. then we can have a few questions. Network transparency empowers users. There's a little thing that we also have to do, which is educate users so they understand what it means to see a particular bottleneck in the network, and just enough about what the internet is so that they understand what they're learning from these tools. Content delivery is the new internet layer. It used to be about IP was the internet. We all worried about how to get packets from point A to point B. It's now how to get content from content producers to content consumers, and that reshapes the world. Technology is never developed in a vacuum with only engineers. It is always in a societal context, and we just learned that over and over and over again. Developed world technologies cannot always be applied to developing world scenarios. We just have to think about these problems. They're constrained in different ways, and they require different engineering solutions. And the ability to program and virtualize, that is, share physical capacity with lots and lots of users, deep into the network is, I think, going to be a critical part of what the network of the future, in fact, looks like. So with that, I'm happy to take any questions you might have. If I have the right to defer.
United States, an individual state, an individual community where the power is dirty. There's a storm, the power goes off. This all assumes, especially cloud computing, that your power is not going to go off.
Yeah, that's a huge right. That's a huge part of the cost, and that's in fact why you might want to put it in the cloud, because the cloud is able to pay for the redundancy in various ways that you can't do in your desktop. And so, one reason you're going to want your applications off your desktop into the cloud is because it will protect you from fried hard disks. Now, what you then have to worry about is that the company you contracted with goes out of business and their disks go away. So, no easy answer to that question. So, I mean, there's lots in software. We understand how to do a lot of things redundantly. So there is a lot of redundancy built into what I've shown you here. But yeah, the problem just doesn't completely go away.
You have governments that are trying to minimize access to internet for political or other reasons. And how are you going to avoid the problem of dealing with these governments like Google had their problems with China?
Great question. And I should have put that one on the list, China, the whole censorship thing. It turns out that a lot of these innovative services that I was describing people have built are extremely hard to censor. And in fact, they're designed. Part of some of the research that's happened is to eliminate to the degree possible the ability to censor. And so you can't, the anonymous behavior is an example that you can't tell where stuff is coming from and you cannot shut it down. And so there are people who have built censor-proof ideas here. The other thing is, the way I always think of it is we provide technology, it is used for both good and evil. And the very things that allow the bad guys to deliver spam and whatnot can be exploited to work around censorship. So it's going to be extremely hard to shut these things down. There's always, it's software. There's always a way to migrate to where they're not looking, so as far as I can tell. Now, that doesn't mean that the Googles of the world can do that. They're too big. But, I mean, PlanetLab is used to circumvent censorship as far as we understand it. It's probably under the radar. We don't know everything that's going on. Yeah, censorship is another one of those issues. Yeah, back there.
Two items, the cloud and anonymity. With regard to the cloud, it seems to me there are some downsides that haven't been discussed. One, of course, apart from your provider going out of business, is you fail to pay your dues and your access to information goes away. You're at a site where you do not have access to the internet and you cannot, in fact, effectively run. I realize there's some backups that will run on your laptop as an intermediate, but it presents a problem. And, you know, you've got all this critical and proprietary information that is sort of sitting out there, in my opinion, not necessarily always accessible and sometimes vulnerable.
So on the accessible part, I think one of the values of the cloud is that it is accessible from anywhere. So the reason I use Gmail is I can get to it from anywhere. If there's a web browser, I can get to Gmail, whether I got my laptop or not. It's in the cloud. And I've got to do the right job of engineering what's inside of the cloud to replicate and move it to where it needs to be. But that I didn't mention that as an advantage, but that is an advantage. But in terms of the risks that you're at, there are a lot of risks. I'm willing to live with them for Gmail. I don't know that I would be willing to live with them if I were making a corporate decision to put my proprietary software there. First, I've got to trust the cloud provider, which maybe I do, maybe I don't. Well, I encrypt it or whatever. But there's actually a faculty candidate visiting the CS department today who has demonstrated how you can just happen to get a virtual machine that's co-located with your adversary's virtual machine on a physical machine and watch through a sort of detective work, figure out what they're doing. I'll just leave it at that. So basically, at a very low level, it's a side channel that you can figure things out. It's not anything part of the design. It's an assumption about the hardware. I mean, all the way down, there are assumptions built into who you do and don't trust. So getting the trust right, I think, is the greatest barrier to pervasive cloud taking over the world. There will be spot cases where we can put services there, though.
Briefly, how do you determine the quality of your anonymizer?
A good question. I don't have a good metric. I don't have a good metric. Yeah.
The New York Times today talked about the dark cloud. Do you see the long-term trend of the dark cloud moving away from a lighted cloud or merging more?
Which is the dark cloud?
Yeah, like Google has your own network. You can assume that the CIA and the NSA, they have their dark cloud, which is separate from the internet.
Oh, the military, for example, has always had their own internet. They forked off from the internet many, many years ago, and they build tactical networks, and they take over the technology as it's appropriate. The military has, focused on the military, I'm more familiar with them than I don't know what the CIA is doing. They've always had a problem of using commodity solutions and wanting to because it's the less expensive thing, and yet retrofitting to them their specific tactical networks and so on. And they're hard at work now trying to figure out how to work around some of the limitations that they see from the TCP/IP internet. That's always going to be the case. So I think, as far as I can see, they will continue to maintain both worlds. At the same time, the soldiers in Iraq they've got cell phones, and they're surfing the web, and they're downloading YouTube. And this whole sort of independent of the military operation, they are on the public internet. And that has a lot of implications. I haven't thought about all of them, but it's definitely one of the problems that they have. I keep hitting up here. Let me come over here. Go ahead.
You said the content was doubling every 18 months. How does that add to the increase in capacity? And now we're heading for some massive traffic jams.
Yeah, we are heading for some massive traffic jams. And the only way we get around the traffic jams, the cost of, there's a very large step function that you have to take, a forklift upgrade to go from one level of capacity to another when you're clear back here where this high speed stuff is going on. And if you basically, I'm not showing you the expand out very well, but if you think about everybody at this side just has some very modest 1, 2, 3 megabits a second. If you just sum all of those up and imagine everybody was trying to download the same thing at the same time, there's no way that you will have the capacity back here. We're talking about several orders of magnitude difference. And so these are becoming extremely fast, but they will never keep pace with the aggregated bandwidth with this edge. And these are, broadband penetration is growing. What I can get into my home, I used to be thrilled with the megabit. It's now 10 megabits, and I'm going to pay a few more bucks and I can get 20 megabits. If you start doing that millions and millions of times over, the last mile is not the bottleneck. The bottleneck is back here. And if what I want to do is YouTube, it's an extremely expensive, even if I could upgrade the technology, it's extremely expensive to suddenly have 40 gigabit connections into the rest of the internet. So yeah, it is going to become a problem. Technology does keep up, but I think that the content is going to stay ahead for the foreseeable future.
What are the implications of the cloud computing for the kind of hardware we're going to have in our homes in the future? I mean, right now I got a tower, I've gigabyte of memory. I've got a backup gigabyte of memory. I've got computing power way beyond anything I need.
Yeah. The promise, of course, is that you can get out of, you no longer have to be your own IT administrator. And in fact, I don't know how to predict exactly, but between living with these and getting rid of the big towers and these, right, this is the future.
I was thinking the iPad also.
Yeah. I'm not sure about the iPad, but
That kind of
that kind of thing. Yeah. That's exactly right. And I will store it. I will have a cache of information nearby, but it will be, for the average consumer, I suspect it's not going to be that long, but you're going to store it on the net because you're getting tired of having to buy the latest version of whatever, and worry about your disks failing and so on.
You mentioned the 4 hours a day of YouTube, for example. How much do you think of the internet usage is for entertainment purposes versus other uses?
Oh, I don't know any figures, but I got to believe it's pretty dominated by entertainment. Yeah, Hulu, Netflix, YouTube. This is what Netflix has been trying to get to is that the cost of moving a 6 gigabyte movie to your home is cheaper via the internet than it is via the postal system. And it's a pretty low rate. The target is not an easy one to hit, but as long as you do the right caching, you can hit it. I don't know what the percentages are, but it's all entertainment.
Yeah,
It's,
4 hours. 4 hours.
and I'm not doing any serious work with 4 hours of YouTube. But just to remind you what I think is happening, my read of what's happening is YouTube is becoming, Google's plan is that YouTube becomes the distribution platform for video, for any purpose. So when I make a video of my research I want to make available, I will make it available via YouTube. And when I do it for my company, I'll make it available through YouTube. Teaching, it is the content management tool. And of course, then you get to slap the advertisements on it, which is how you generate revenue from that.
To your point, just to that point, a lot of companies are actually blocking YouTube. For example, like Fortune 500 companies are blocking it.
And that might be what keeps YouTube from becoming the pervasive video distribution technology. Google goes to a lot of effort to support YouTube. In fact, one of the things that they will do is they will come and put a cache on that side, the operator's side of that peering point. But there's nothing that an operator hates more than hosting somebody else's hardware on their side of that peering point. But they've been forced out of necessity to do that. Yeah, I'm not surprised to hear that YouTube's being blocked. But the goal, again, is to carry everything, including legitimate video.
What happened to Internet 2.0?
Internet 2 exists. I'm not exactly sure what you're referring to, Internet 2.0. Internet 2 is a research network that serves, its clients are the high-end scientific users at American universities.
Okay, was that ever supposed to go into the consumer?
Because they have high bandwidth demands, you can view them as guinea pigs for the next generation of technology. They tend to focus on bandwidth. If you're trying to get data from the super collider and you're a business, then all you care about is moving very, very large files. And that will drive demand on the bandwidth, which they would then hope that the government would pay for. But that end of the spectrum has very modest impact on the commodity internet. They do things faster before everyone else does, but they don't really. Facebook didn't come out of Internet 2. YouTube didn't come out of it. None of the stuff that's commodity and widely used comes out of the scientific community that drives Internet 2.
Can you talk a little bit about national security? We see in the paper all the time that
Yeah, great question. I'm not sure what to think about that problem. On the one hand, I know there are vulnerabilities, and I'm sure our adversaries know about vulnerabilities. On the other hand, the internet is such an amorphous thing. It's very difficult to widespread attack it. I mean, there are some vulnerabilities, and they've been exploited from time to time. I tend not to lose sleep over it, because probably if I thought about it too hard, I would be too worried. But I mean, it's a good thing that we're finally starting to pay attention to this, and that was one of the driving motivations behind trying to innovate. And this whole ossification problem is we're stuck with today's internet. Today's internet is vulnerable from a security point of view, but we can't innovate the next solution because we're stuck with today's internet. And part of the answer is there are some things you can do to make the internet resilient on top of today's internet. And that's what most of the work has happened. It's not actually changed the routers and the IP stuff at the core, but it's done stuff on top to make it more resilient. There are still vulnerabilities down in the routers.
Last
Who
question.
owns the regional data centers?
These are typically owned. So there are carrier hotels in major cities where different organizations will co-locate their services. I don't know actually who owns them. There's one in New York City. I'm not sure about how exactly who owns it versus who just rents space there.
Verizon or Comcast?
Yeah, AT&T, yeah.
Oh, they would have.
Before, you mentioned how Europeans are more interested in privacy and the U.S. maybe in free speech in relationship to this Google Italian case. Can you flesh that out a little bit? What do you think is going to happen with that? Where are we going to do? Are the content providers going to be worried more and more?
Yeah, I don't know where that one's headed. That was a total shock. I mean, it's not a total shock that the Italian court came down on the side of privacy. What was a total shock to me was holding Google responsible for that. I mean, they didn't produce the video; they carried it. YouTube is kind of it is the source of the data in a sense. It gets uploaded to YouTube. So unlike some of this other stuff where carriers are not held responsible for what's in transit, they're a little bit more responsible for. But yeah, that's what will really, if that takes root, that just changes everything. I would be shocked to hear it, but I would be very surprised if that part of it takes root. I don't know what's going to happen. I think there's going to be a long-term battle on the privacy versus free speech issue. I mean, on PlanetLab we hit it all the time where our European partners say you can't do that. Yeah, I don't see that one going away anytime soon.
Thank you very much, Larry.